Hi, my name is Serena, and I am part of the FLL team Just Team Pi. Today, I will be giving a quick introduction to attachment design in FLL. So, in this video, we'll learn about key design principles, the attachment design process, passive attachments, active attachments. We'll do a quick practice activity to identify whether an attachment is passive or active, and then we'll work on passive and active combined attachments. Here are some key design principles. For your attachments, make sure that they have easy slide-on structures. Those save time to remove and put on in the competition. I suggest using half-pin half-axles for attachment points and beams for easy removal but secure holding. Also, have the same base for all attachments, so they all fit the robot in the same way. This makes it so all attachments are attached the same way and is less confusing to build and attach or remove. Next, since FLL allows two motors to be used for attachments, we can use the two motors to power two different movements, making the attachment twice as efficient. You can see an example attachment on the bottom right. This one was able to solve two missions using only one attachment. Even more passive functions can be integrated on the side. We will talk about passive functions a little later in this video. And finally, make sure the attachment is robust, meaning that it's consistent every run without wobbly parts that can cause slight offsets, and secure and not easy to break so that it doesn't need to be rebuilt. A wrongly built attachment affects the entire run. Next, let's move on to the attachment design process. This is a basic diagram of the attachment design process. First, analyze the mission or missions you would like to solve. Try to figure out the type of movement you want to accomplish. For example, if I had a mission where I needed to press a button, I'd make sure to remember that I need a downwards pushing movement. The next step is to build a few prototypes with different ways of completing the needed movement. To push a button, maybe I use an arm or a rack and pinion. How should I decide which mechanism is better? I'd move on to the next step, which is to try and combine the attachment with other attachments and integrate them into preliminary runs. At this point, try to see which attachment is more consistent and fits better into the run. I'll decide to use the arm since it doesn't get in the way like the rack and pinion does. The final step is to keep iterating and improving the attachment, possibly to get it to be more consistent or fast. Now let's talk about passive attachments. Passive attachments are attachments that don't use motors. Let's look at some of the examples below. First off, the wedge is a great tool for consistently pushing missions. The shape of the wedge is very easily changed, making it pretty versatile. My team used this in the past Unearthed season. Next, the one-way door is very helpful. It can be made to grab things of all sizes, from flat hoops to taller elements like flags. I feel that I've used one-way doors every single season since I started FLL, which was 4 seasons ago, for a variety of movements. Finally, the aligner helps your robot align to walls or around the base of a mission. This makes the robot's position very precise and drastically improves the consistency of an attachment. This is a very common type of passive attachment. Next, let's talk about active attachments. Active attachments are attachments that do use motors. Again, let's look at some examples below. The lift arm is very common. This is just a basic version. There are many types of lift arms. Every season, FLL usually has elements with rings to grab. Lift arms are a great option to execute these types of movements. The grabber is used to swipe things from the ground. It can act as an openable gate when delivering elements. Finally, to the very right, the rack and pinion has a horizontal or vertical pushing motion. It can be used to push or slide in a straight movement. It's like a lift arm, but without the circular rotation. Now it's time for a practice activity. Is the attachment passive or active? Feel free to pause the video to answer these 3 questions. Remember that gears usually transfer energy from a motor, so it's a good tip to keep in mind that if you see gears, usually the attachment is active. So, first question, is the attachment passive or active? I'll give 3 seconds. Yes, you're right, this is a passive attachment. Next, is this attachment passive or active? Yes, you're right, it's active. And finally, is this last attachment passive or active? This one's a tough one. Yep, it's passive. It's a one-way door like we talked about earlier. Now, this is a trick question. Do you think this attachment is passive or active? Let's take a look. Well, first off, I see an active grabber like we saw before in the slideshow. And then I also see an active slider mechanism. I can confirm that these two are both active by seeing the gears at the top. But on the bottom, somehow I also see a passive aligner. How can this be possible? Is this attachment passive or active? Well, this is a trick question because this attachment is actually both. When passive and active attachments are integrated together, it allows for more than two powered movements. This means more missions solved with more movements and more time saved, since there will be less runs and less attachments to manage. These example attachments have passive and active elements circled. Look at how each element adds a useful function. I highly recommend for an advanced team to try and do passive and active movements combined into one attachment because it really saves time and makes runs a lot more consistent and efficient. Thanks for watching this video. Make sure to like and subscribe so you can be notified when we post more FLL tutorials. If you have any questions, feel free to leave a comment down below or reach us through our email.